Most of my videos on stats have focused on using SPSS as a method or mode of analyzing your data, but a lot of people don't have SPSS, especially if they're not in a university where they can generally get it for free because the university pays for the subscription. But most people generally have some type of access to the Microsoft Office software, and included in that obviously is Excel. And Excel does have some inbuilt data analysis add-ons. This is not talking about the functions which you can use to perform statistical analyses, but rather a standalone package which does a lot of the main functions that the previous videos have gone over. So this is a tutorial which just briefly goes over using the Data Analysis ToolPak, which comes with Excel, and how to get it going and start doing some analysis. So generally by default the ToolPak is not activated, so you'll have to activate it going into options, add-ins, and then you'll see the Analysis ToolPak here. So you can just click on it or make sure it's highlighted and click go, and then a little window will pop up here and you just click Analysis ToolPak, and there are others which you can download, but we'll just go over the inbuilt one today. So once you've clicked on it, you just click OK, and then if you go to the Data tab, you'll see the little Data Analysis button has established itself here. So that's pretty much how you can get it going, and data analysis next, just to go over some of the functions. Okay, so I just made some random data which we're going to call variable 1 and variable 2 using the rand between function in Excel, which generates random numbers between 2 points. So rand between 1 and 10, or rand between 1 and 15 for variable 1, and rand between, I think it was 10 and 20 for variable 2. So anyway, let's check out this data analysis options. So you can see that most of the common statistical analysis methods on here. You get single factor ANOVA, two-way ANOVA, and repeated measures ANOVA, correlation, covariance, descriptives, exponential smoothing, f-test, two-sample variances, Fourier analysis, histogram, moving average, random number generation, and rank and percentile. So just to see how it works, we're going to start off with some descriptive statistics, which one generally does anyway. So you can see we need to enter our input range and whether they're grouped by columns or rows. In our case they're grouped by columns because each column represents a different variable, and the labels are on the first row. So let's select our range, A and B, and then you can choose where your descriptive output will be set to. So you can either set an output range on the sheet you're working on, or you can just make it so it generates in a new sheet. And you can choose what statistics you want to generate, so your summary statistics, confidence levels for mean, the largest and the smallest values, the number of them. But we're just going to use summary statistics and confidence level for the means. We're going to click OK. You can see in sheet 2 here, which has moved to the main one, or the first one. You can see it gives us the mean for variable 1, the mean for variable 2, standard error, the median, the mode, standard variation, standard deviation and the sample variance, and the kurtosis and skewness, which we can use to determine the normality of the sample, or normality of the means, and as well as the range, the sum, and the overall count, and the confidence level of the mean. So it's pretty default stuff, but it's useful to be able to do it in one go as opposed to calculating all of these statistics individually, which can become quite tedious. So let's move on to a different type of test. Let's assume that these are independent variables and they're not repeated measures. So let's look for an independent samples t-test, and let's assume that these have homogeneous means. We can do a test for that, but let's just move on from that and do some stats. So variable 1 range is variable 1 and variable 2 is variable 2. Labels are included. Hypothesized mean difference, I actually don't know. But I suppose if we look at the descriptive stats we would get an idea. Let's see if we can use it without it. So here's our output. We get the mean, variance, number of observations, the pooled variance, the hypothesized mean difference, which we didn't really add. So I suppose if we added a 0, we assume there's going to be no difference between them. And here's our t-values and our p-values. You can see in both in a one-tailed and a two-tailed example that there's a significant difference between these two scores. 0.009 and 0.018. So yeah, that's independent samples t-test done. Okay, so let's move on to something a little bit different. Let's see how the correlation would look in Excel. Input range A and B, labels in the first row, and they're grouped by columns. And we want it in a new worksheet. So it gives us a little correlation matrix here, and I assume that is representing R. It didn't really give us an option for Pearson's R or Spearman's row, but by default it's generally Pearson's R, so I assume that's what it is, and we can see that's a negative correlation there. Unfortunately it doesn't give us the p-value, but I suppose you have to take what you can get, right? So that's pretty much it for this introductory tutorial. But if you have any questions regarding a specific type of analysis using the Analysis ToolPak in Excel, just leave a comment and I'll try to do a little tutorial if I can, and otherwise explain it if I can't. And if you like this video or found it useful or for some reason interesting, give the video a like, and if you'd like to see some more of these types of videos, please subscribe to the channel.